Today, OPC UA for shot blasting technology is our topic, and today we have here Dr. Martin Riester from VDMA Surface Technology and also Christopher Lear. He is doing the editorial of several OPC UA companion specifications and is from the VDMA Machine Information Interoperability Department. And with this, I directly hand over to Martin and Christopher. And yeah, I'm excited about the deep dive content we are expecting today.
Well, thank you, Andreas, for your kind introduction. And I will make the shallow start and introduce into shot blasting technology, what is this technology about, and inform on the framework which we have for OPC UA in surface technology, and then Christopher will take you to the deep dive. So as I said, working group structure is my part, and information model overview will be the bigger part, and that will be Christopher. So in VDMA Surface Technology, we have an initiative together with the OPC Foundation in the working group Surface Technology Initiative. We are taking care of machine-to-machine communication standards, meaning the information models on how the various machine types in surface technology communicate. We have 4 groups. One is coating technology for organic coating materials, which is alive since 2018 already. Then we have today's topic, shot blasting technology. This group started in 2021. Plasma surface technology worked in parallel to shot blasting and is part of our session on Thursday. And then currently we started cleaning and pretreatment technology, and that makes up the 4 working groups we have in surface technology. To give you an overview of the different character of these groups, for coating technology for organic coating materials, the challenge is a bit different because in this technology field, we have several machine types which are relevant for the process. So we will be drafting various companion specifications, and because these machines also have to interact closely among each other, we are also focusing on machine-to-machine communication and not only on machine-to-MES communication. So we have a specific modular approach that all the information models will be comparable with abstract types for components and systems and so on. That's the big topic in coating technology for organic coating materials. For shot blasting, but also for plasma, we only have to cover one machine type, and that makes it far easier. And we are looking in this information model or in this companion specification only on the machine to MES communication. And to round it up with cleaning and pretreatment technology, this is similar to the first, the coating technology of organic coating materials, because cleaning and pretreatment is also part of a coating line. So similar approach for that one. But today, focus companion specification for one machine type, shot blasting technology. What is shot blasting technology? Just a brief view to that. The technology is basically you apply accelerated shot, means particles, steel or corundum or nutshells, whatever, to a surface, depending on the choice of shot is depending on the result and the substrate you want to treat. So the effects you will reach with shot blasting is roughening or smoothing a surface, also cleaning. For instance, when you have die casting, for instance, you have to clean your work pieces later on, and that's where they apply shot blasting in that industry. But also solidifying, hardening, or introduction of residual compressive stress. These three are topics of so-called shot peening, where the particles are not abrasive, but you have more or less spheres which you shoot at the surface and improve the material properties over there. And we have two machine types basically, and they only differ on how this shot is accelerated. Wheel blasting machinery, you have rotating wheels or turbines which throw the shot onto the surface of the workpieces, and for air blasting you do this acceleration of the shot by pressurized air. That's the basic difference, but you will find both machine types in the information model. That is just some physical background here. So just as a wrap up, we have the core working group 2 on shot blasting technology in our surface technology initiative. The project started in March 21, and we received VDMA MII support since March 23. And the industry members are listed on the right side, and we are ready with the information model at this point, but the group said that they want to deal with this result of work for the next couple of months before going to publication. So we expect that the companion specification draft will be published in fourth quarter 24 as VDMA 4718. And that's it from my side. Short introduction, and now I hand over to Christopher for the deep dive.
Okay, thank you very much, Martin, for the introduction to the companion specification for shot blasting technology. I will talk about the actual content of our companion specification now. At first, I will give you an overview of the content, and then we will have a look into the information models. So the first question that you have to answer in developing an OPC UA companion specification is which machines should be mapped and which manufacturing processes of these machines should be mapped in what depth. So maybe this sounds obvious, but if you don't really define what exactly machine you want to map in your companion specification, then you have a big problem because you don't know how to design them. So the first answer you have to find is on these two questions. If you then know which machines you want to design the companion specification for, then you can define some use cases that should be fulfilled by this information model. And in our example for the shot blasting technology, I brought a few use cases that we want to map at this point, or that we are mapping. So a first use case is to get an overview of the production parameters. So for sure, if you want to have a look into the information model, then the idea is to find some parameters that are currently running on the machine. So you want to know what your machine actually is doing and in what way with which parameters. Another use case that we are fulfilling in this companion specification is to get an overview of the machine status. So what is my machine doing? Is she working? Is she broken or anything like this? So these statuses are very important to monitor. And that's why one of our use cases is this overview of the machine status. Another use case is to connect and identify the machine to a higher level network in a standardized manner. So if we are developing a companion specification, and by that an information model for our machines, but the identification is done separately by every manufacturer, then this is obviously a problem. And by that, we want to make the identification of the machines for sure standardized. And this is actually a very important point. Another use case we want to fulfill is providing information for KPI calculations. And the last use case I brought here in this presentation is the harmonization with existing standards. And as you see on my slide, the harmonization with existing standards is highlighted here. And I highlighted it because this is a very important topic in general in OPC UA and OPC UA companion specifications to use previous work. And I will show you in this presentation as well how we did this, how we used other companion specifications. So after the use cases are defined, you can start to build up your parameter lists, define the parameters that are necessary to fulfill these use cases. And as Martin already told you, we have two different kind of shot blasting machines. And by that, we for sure have to look, are there any differences in the parameters and so on? So we have the wheel blasting machines and the air blasting machines that are accelerating the shot blasting media on a different way. And it's very important to look again at the first two questions. They have to be answered. You have to exactly know what machines you're talking about. If the parameter list is finally completed, you can think about the modeling approach that you want to attack in this companion specification, and then you can start to model your informations in the information model. So this is how we were doing the work in the shot blasting technology working group. And I told you that one of our use cases was the harmonization. And the harmonization is very important to be harmonized with other companion specifications, not to remodel all the work that has been done already. And a very important companion specification that is one of the base specifications in the OPC UA context for the machinery industry is the OPC UA for machinery. And I give you a very short introduction to the machinery specification because this is important for our information model because we used some blocks of this specification. So the machinery is a companion specification that is made for the whole mechanical engineering industry. And in the machinery specification, there are some use cases defined, and these use cases are solved by specific building blocks that can be used in other companion specifications or even in information models that are not standardized. So you can always take the machinery specification and take the parts that you are interested in, take them into your specification. And that's exactly what we did in our companion specification for shot blasting technology. And by that, you can see that we are fulfilling at this point the target image of the machinery. The target image is that the OPC UA for machinery specification is the base of every companion specification in the field of the mechanical engineering industry. And same as, for example, the laser machines are doing this, we are basing our companion specifications for shot blasting on the OPC UA for machinery. The machinery specification has or is structured in 4 different documents. It's the basic building blocks, the process values, job management, and result transfer. And you can see here now what parts of this machinery specification we actually used in our information model. So we used the machine identification the component identification, we use the block finding all components of a machine, the state machines, and the counters. And additional to that, we also use the job management specification. And now I will show you by look into the information model, where we used these blocks, how we used it, and how the rest of our information model looks like. So the entry point in every shot blasting machine is the shot blast machine type. So we defined an object that is called shot blasting machine type, and underneath this object you find every node that is mapped to our shot blasting machine. And on the following slides now I will build up this shot blast machine type and explain you each block that we added here, and each information that you can find in these specific blocks. The first block here is the of the shot blast machine type is the identification block. And as you can see in the type definition up here, it's the machine identification type from the machinery specification. And the machine identification type from the machinery is now visible on my slide on the right side. So if you are implementing this building block, then you can access all of these variables that are visible now. So we have information about the manufacturer, we have information about the model of this machine, hardware and software revision. We can add the serial number, the year of construction, month of construction, and also very important, the initial operation date, so the date when you set up your machine in your machine park first. So as you see in this box here, the machine identification type is a very accurate identification object, and this is a standardized identification for all of the machinery industry. So at this point we are harmonized by using this building block with all the other companion specifications from other branches that are using this building block. Besides the identification building block, we also implemented the machine components type structure. And the machine components type structure is also a machinery building block for sorting the components of a machine. So inside of this object, you find all of our components that we are implementing in a shot blast machine. And this component folder is ensuring that every higher level system, every MES system that don't know the companion specification for shot blasting technology can find the components of a specific machine in a standardized way. So on the right side in the box, you find the information from the machinery specification for the machine components type. So this machine components type is fulfilling the use case to find all components of a machine. And inside of this components structure, we have objects for the shot blast chamber, for the hopper, the refill silo, the pressurized boiler, the conveyor, the filter system, and the blaster. So for each of these components that can be used here in this shot blast machine, we defined a specific object type, and all the information and all the parameters and variables that are necessary to monitor and control these components can be found inside of these objects. I will not give you an insight now in each of these objects because this is going to take too long. But in the end of my presentation, I will give you a short insight to the blaster type as an example for a component at this point. Something else I have to mention here is the filter system type. So the filter system type is also not designed by our working group, but it's an object that we took from a companion specification that is already existing. And yeah, I'm talking about the OPC UA for process air extraction and filtration systems. So from this companion specification, we've implemented the filter system type because we saw that the filter system they designed is fulfilling the needs that we have. And yeah, by that we want to harmonize, and yeah, we integrated this block. If you have a look in the filter system type, so this is now a screenshot from this process air companion specification, then you see that you have a lot of possibilities, a lot of components that you can add to this filter system type to exactly describe your filter system. On the right side, you see that most of these nodes are optional. So if you don't want to have a too complex filter system, then this is possible with the filter system type. But if you want to yeah, go in detail with your filter system, then this is also possible with the filter system type of the process air companion specification. Okay, so this is the components side now. And in addition to the identification block and the components block, we also added some other nodes to our shot blast machine type. The shot blast media type that you can see on the right side here is giving you all the information about your shot blast media. So we defined an object that is carrying the information for who's the manufacturer of the shot blast media I use, what is the particle size of the shot blast media, what is the hardness of our shot blast media, and so on. So all of these information who are very important for the shot blasting process can be found in the shot blast media type. And beside the shot blast media type, we also implemented a monitoring folder that is yeah, giving you all the or giving you a place to put all the monitoring variables, monitoring information that are suitable for the whole shot blasting machine. So if the whole machine has some parameters, some variables to track, then they are structured in the monitoring folder. And in the monitoring folder, we have the consumptions of our machine. So we defined a consumption type that can be used to map shot blast media consumptions, water consumptions, electricity consumptions, and pressurized air consumptions. And all the other consumptions that you can imagine can be yeah, mapped by the consumption type, and they should be placed in the monitoring folder in our shot blast machine type. So this is the main information model for the shot blast machine type. And in addition to the nodes that you can see now, we also added some extra building blocks from the machinery specification that you can now see in the middle here. And now I will very shortly go through all of these blocks and tell you what you can solve with these blocks and yeah, what you can do. So let's start with the lowest block, the job management block. Job management is, as I showed you earlier, a document from the machinery that is yeah, handling the job management of a machinery. So in the OPC UA for machinery part 3, you find this this block that we implemented here. And with the job management type of the machinery, you can map a whole job handling system. So in this document, you can find the definition of the mechanism how to exchange data between higher level systems and machines. And you've also find the information how these information should be structured. So you find the job order definition, you find the definition of the job result. So what parameters, what variables should be in the job order and in the result. You find this information here in the job management specification of the machinery. And even a job state machine is designed here in the job management specification. that can give you the information for each job in what state it is. Beside the job management building block, we implemented the machinery item state machine type. So the machinery item state machine is a state machine with 4 different states: not available, out of service, not executing, and executing. And yeah, the not available state is telling you that the machine is not reachable for any reason. For example, it's turned off. The out of service status tells you that the machine is blocked for any reason, or it's broken. The not executing tells you that the machine has no problem, but it's just waiting for a job, waiting for another machine, and so on. And finally, the execution or executing state tells you that the machine is currently in the execution mode. And in the example of the shot blast machine, the machine is shot blasting a part. So this is the state machine that we've implemented here. And beside this state machine, the machinery also gives you another state machine, the machinery operation mode state machine. The machinery operation mode state machine tells you what you actually planned for the machine. So if you don't have any plans, then you're on the state none. If you want to make maintenance works, then you are on the state maintenance. Then you have a setup state. And for sure, you have a processing state if you want to work with the machine. And for sure, this information can't be set by the machine. They have to be set by an upper laying system. And if you want to use this state machine, then the MES system, for example, has to feed the information model with this information. Why did we implement both of these state machines? We implement both of these because if you have both of these state machines, then you have all the information that are necessary to enable KPI calculations according to the ISO 22400. So in the ISO 22400, you find the availability KPI number, and with the information from the state machines, you can actually find out what availability your machine has. Another building block we've implemented is the machinery lifetime counter type. The machinery lifetime counter is a lifetime counter. I brought here an example. It's always easier to explain this counter with an example. So the lifetime counter is fulfilling the problem if you want to count down or count up something. So if you, for example, say after 1 year you have a major inspection for your machine, then you can use this counter by setting the engineering unit to days, the start value to 365, the limit value to 10, and the indication to 0. And by that, if you reach the limit of 10, then you get the information that soon your inspection has to be done. And so with this counter, you can fulfill every use case of counting up or down anything. And in this case, the lifetime variable has the value 120 now. So this means in 120 days, this counter ends and we have to make the major inspection. And the last block that I brought now and that we've implemented to our information model is the machinery operation counter type. And this is a typical counter, I would say, because with the machinery operation counter type, you can count the power on duration of your machine. So how long is my machine powered? You can count the operation duration. So how long is my machine in an active state, is actively doing something? And then we have the operation cycle counter that is counting a cycle. So you can define for your machine what a cycle is. I personally don't know now what a cycle for a shot blast machine is, but I guess you as experts from the industry know that. So if you define a cycle, then you can count how many cycles did my machine made. So these are the building blocks that we additionally implemented from the machinery specification. And whenever you implement something from the machinery, then you have to structure these building blocks in the machinery building blocks folder. So the machinery building blocks folder is a structural folder on the first level of your machine. So as you can see here, the shot blast machine has on the first level the machinery building blocks folder. And from this folder, you have an additional reference to each machinery building block that you've implemented into your information model. And you are doing this to make sure that an MES system, for example, that don't know the companion specification for shot blast machines can easily access all the information that are implemented in this information model according to the machinery specification. And it's done by the idea that this MES system don't have to browse all the information model. It just can go to the entry point of the information model. It's in this case the shot blast machine type, and then go to the machinery building blocks folder on the first level. And from here on, it finds all the machinery building blocks. Yeah, so this is the idea of the machinery building blocks folder. And here you see a screenshot from this specification that is explaining again what the machinery building blocks folder is for. But I just did it just now, and that's why I skipped this now. So here you see the information model that we designed in our working group for shot blasting machines. And this is everything you find in the shot blast machine type. As I promised you, we also have a look into a component, in this case in the blaster type. So the blaster type is looking like this. We have the machinery component identification type. So another machinery building block here. It's pretty similar to the first identification block that we saw, but the first identification block we saw was the machinery item identification type, and this is the machinery component identification type. And the difference between these two objects is just that there's one variable that was in the other identification is missing here. It's the location variable, because a component don't need the location. And there's one additional variable as well. Beside the identification, we have another structural folder that is called monitoring here again. And inside of this monitoring folder, you find all the variables that are standardized for the blaster type. So we have the shot blast media throughput, the shot blast media throughput percent, the shot blast time, shot blast pressure, and the real rotation. Down here you see again the machinery building blocks folder. It's because we've implemented here the identification block for the machinery, and as I told you before, the rule is then to also implement this folder. I want to give you one hint now at this point. If you are implementing the companion specification for shot blasting technology, then you have, as you see, a base of the information that you need for your machine. But if your machine can has a few more parameters, has some special features and so on, then it's no problem at all to extend this information model. As long as you don't change standardized nodes that we've defined in the companion specification, you can add anything you want. So I just brought an example here. If you have a wheel temperature and a wheel vibration variable, then it's no problem at all to add these variables to your information model. You're still suitable to the companion specification, and by that suitable to the standardized information model. You can also add objects like I did here. as example, I added a lifetime counter and a blaster state machine. And you can add whatever you need for your use case, as long as you are fulfilling the standardized blocks that we defined in the component specification. It's fine for the standard. So this is the insight to an exemplary component, the blaster type. And by that, I'm done with the content of this component specification. So here you see again an overview of the shot blast machine type, what is in our case the entry point to the information model. As Martin already told you in the beginning of the presentation, we are actually done with the content work. And now in the next month, our working group members want to prove if everything is working out with this component specification. They want to collect some experience and test what we designed. And after this is done, we will publish the release candidate of the component specification for shot blasting technology. And this will be end of the year. So if we're going to the publication, then the component specification will be uploaded here on this VDMA page that you can see on the slide now. On the right side, you find the link that is guiding you to this page. And on this database, on the VDMA homepage, you find all the component specifications that were published by the VDMA and all the release candidates as well. When we publish the release candidate, there is a 3 month of time period where you can comment this release candidate and give some feedback. Yeah, but the publication will be end of the year, and if you are interested, then Martin Riester and me will be happy to answer all your questions. You can contact us, and we can give you more insights. We can help you out with all the questions. So by that, I'm done with the content presentation, and I would say if there are any questions or any comments about that, then this is the right time now. Thank you very much.